These are the steps of hypothesis testing that we talked about in class. Anytime a person is doing a hypothesis test, the person will go through these same 7 steps. Once the person gets to step 4, the person has to decide what type of formula should be used to calculate the test statistic, because there are different formulas that could be used. Each formula is usually named with a certain letter, and the person has to choose the correct formula to use for the type of data that he or she has collected and for the type of question that he or she is trying to answer. If the person is interested in a correlation, the person will calculate R as the test statistic. But if the person is interested in whether 2 populations have equal means, the person will calculate T as the test statistic. And R and T have different formulas. And ZF and chi-square are other types of formulas that can be used for the test statistic. And these formulas are used in other types of studies that we haven't covered yet. So once a person gets to step 4, the person will choose the correct formula to use for the type of data that he or she has collected and for the type of question that he or she is trying to answer. And after that, the person will move on to step 5 and determine if the test statistic falls in the rejection region. Then the person will make a decision about whether to reject the null hypothesis, and then the person will make the final conclusion. So steps 5 through 7 are done the same way, regardless of which formula you use to calculate your test statistic. So far, we've been talking about studies in which R is used as a test statistic. When R is used as a test statistic, the name of the hypothesis test is hypothesis test of a correlation coefficient. So far we've been talking about a certain type of test called the hypothesis test of a correlation coefficient, which is just a test in which R is used as the test statistic. In a hypothesis test of a correlation coefficient, the person calculates the sample correlation coefficient, which is the letter R, to make a decision about the population correlation coefficient. In other words, the person looks at the correlation in his or her sample to make a decision about the correlation in the population that the sample came from. And there are actually 3 different versions of this test. So far we've been talking about a certain version of the test, which is called a two-tailed test. And right now I'll explain what a two-tailed test means and what the other 2 versions of the test are. The two-tailed test is used when the researcher isn't reasonably sure whether the correlation in the population is positive or negative. In class, we were talking about the correlation between the number of children a person has and the number of hours that the person works per week. If we're studying a certain population of people, and we're wondering whether we're interested in the correlation between hours worked per week and number of children in that population, it would be difficult for us to decide ahead of time whether we think the correlation is positive or negative, because it could be that in the population that we're studying, people with more children tend to work more hours per week because they need to make more money to support their children. But it could also be that people in the population who work more hours